So Katie, are you with us?
Hello.
There you are from far, far away. Katie's coming from a remote location this time, so if she starts to fade out on us, we'll jump in for you. But
Great.
what do you have for us in terms of pretty pictures and space weather? Let's take a
Yeah.
look.
This first image are my favorite types of clouds. They're lenticulars over a mountain range, and lenticulars generally form over mountain ranges. And this was taken by Nicholas Gascard. And he also took this next image of a lightning storm, just a gorgeous image from Italy, this one, and on September 9th, 2021. And then on April 17th, SpaceX launched a Falcon 9 rocket from Vandenberg in California. And this spiral you see here was caused by the post-deorbit burn fuel vent of the Falcon 9 upper stage, which deorbited over the Pacific Ocean. So this was captured by the Subaru telescope on Mauna Kea in Hawaii. And a beautiful crescent moon, this was captured by Anthony Perkic. And this is Orion right in the middle of the image. On the left is Canis Major, and on the right is Taurus. This was captured by Todd Kunioka, who's a telescope demonstrator from Griffith Observatory. And this is from Snow Canyon State Park in Utah. Here we have the Como cluster. This was captured by Anthony Perkic, and the Como cluster is a cluster that has over 1,000 identified galaxies. And here are just some of those labeled. So that's an incredible photo from Anthony. And another one from Anthony, this is star Nebula from Leo. And if you were able to wake up early on April 30th, you might have seen the conjunction of planets Jupiter and Venus. That's on the bottom left of this image. In the middle is planet Mars, and on the top right is planet Saturn. And there are labels. See that. This is from Joshua Tree National Park from Anthony Perkic. And then Todd Kunioka, the next day from Joshua Tree, took this on May 1st of the conjunction. And on to some solar system weather. This is the current solar cycle progression. The red line are predicted sunspot values, and the black dots are the monthly values. So we're on our way to solar maximum in 2025, and the sun has been very active this past month. So while sunspots are cooler regions of the sun, the photosphere around them sometimes erupts with outflows of high energy particles called solar prominences. That's on the left, and you can also see the approximate size of Earth to see how big those are. And solar flares, on the other hand, are powerful bursts of radiation. There's the difference between those there. And Anthony Perkic captured this photo from April 21st of sunspots that have been active this month. 2996, 2995, 2993, and 2994. And sunspot 2993 caused a double solar flare on April 25th, which actually caused a long-lasting radio blackout over Southeast Asia and Australia. And this GIF is of a coronal mass ejection headed toward planet Mercury, and it actually caused Mercury to appear like a comet. So this next image is Mercury's sodium tail taken April 27th. That coronal mass ejection was the 11th. This is by Dr. Sebastian Voltmer. And I believe this was also the astronomy picture of the day. And of course, the beautiful Pleiades above planet Mercury. And here's a close-up from Sebastian as well.
Wow.
And just to show you a little bit more of how active our sun was this past month, we had an X-class flare, which is the most powerful class flare, April 17th, April 20th, an M-class on the 22nd, and then an X-class on the 30th, and then another X-class on May 3rd. So the sun is very active right now, and if we're lucky, in some spots of Earth, we can see beautiful aurora from the solar activity. So this one was taken by Göran Strand in Sweden. This is a 360 panoramic view taken in mid-March. And then Göran also captured this one of the Milky Way with northern lights. And Nicholas Hjort took this video to close out pretty pictures. This is from April 9th from Abisko.
I like those satellites flying through the image that you see. Heading every which way, it seems.
Yeah.
So beautiful. So more solar activity, maybe some more aurora.
Just fantastic, Katie. Thank you so much for these beautiful pictures and the aurora. Really, really fascinating stuff. Somebody in the chat wanted to know why we don't get hit by more solar flares all the time. Well, the solar flare is the eruption on the surface. Like Katie said, high energy is deposited right there on the surface. It can lift a prominence up off the surface of the sun, and it can cause a coronal mass ejection. And it's that mass traveling from the sun that spreads out into space that does in fact interact with us. It causes the aurora borealis, like you saw there. So we are hit quite a bit by them, but as we head towards solar maximum, they're going to get stronger and stronger. So our magnetic field protects us for the most part. But recently, there's been a lot of radio blackouts. If you're somebody that listens to shortwave radio, or you like doing that sort of thing, there's been blackouts where the radio signals just don't travel and don't bounce off the ionosphere because the coronal mass ejection interferes. So interesting stuff, and great question.